Um, what are the intrinsic time scales within a season for the monsoon? You can see here multiple years are shown with the climatology of long-term mean being shown as this envelope here, and over that you have red, which is below that long-term average, and that is called a break period when the rainfall stops for a few days to a few weeks, and it is blue here, which is above, which are called active periods where it's raining over the so-called core monsoon zone, for example, over the central India Gangetic Plain and Indo-Gangetic Plain as it is referred to. So the season is made up of these active and break periods, and if you look from year to year, the seasonal mean rainfall is different. So this is only 691 millimeters of rain over 4 months. This is more than 1,000 millimeters, and this is even less, 640 millimeters. Is there a relation between active break periods and the amount of rain? It would seem so, because when the rainfall is less or lower, like 690 and 640, there seem to be more reds. So there are more break periods during drier years than during wetter years. You can see this 94 wetter year has many more blues and very few reds. So the seasonal rain is made up of these active periods and break periods. So there is some intrinsic time scale that is being picked by the large scale dynamics that is controlling the monsoonal circulation, and this topographic driven ocean coupled system that we looked at, where the rainfall was happening with marine ITCZ remaining there and rainfall over Western Ghats, Himalayan foothills, Bay of Bengal, Burmese mountains, and so on. So not everything is understood exactly why this scale selection happens, but there are also other features, other modes with this similar time scale, which is less than a season, something like 30 to 60 days or 30 to 100 days, because this is approximately a season. So these are called intra-seasonal time scales. Intra-seasonal, you can think of it as less than 90 days. Okay, so monsoon seems to have this intrinsic time scale of intra-seasonal variability. And talking about El Nino, 1972 was a strong El Nino. 94 was a weak El Nino, but there was an El Nino-like thing happening in the Indian Ocean, which is called the Indian Ocean Dipole Mode, or some people call it the Indian Ocean Zonal Mode, because there's a long debate about whether it's a real east-west dipole or whether it's a monopole, and so on and so forth. Nonetheless, 2002 was also a El Nino, but it was a so-called Central Pacific El Nino that we talked about. So there are some arguments, some papers arguing that Central Pacific El Nino, when the warming remains near the dateline and the Central Pacific, the Indian droughts tend to be stronger. Okay? Whenever you talk about these things, one thing, if you're a statistician, is that there are never enough number of samples to claim statistically significant differences, but nonetheless there are papers which look at these things, do correlations and other things, and argue for these things. So even global warming seems to be projecting onto these active and break cycles. This is a paper from Deepti Singh and Noah Diffenbaugh from Stanford University. Deepti is somewhere else now, up in Washington State. So it is showing the impact of global warming arguably on the monsoon. So extreme wet spells, composite anomalies, extreme dry spells as composite anomalies. And I won't go into the details, but I would just say that the argument in this paper is that the dry periods within the season, or the break periods, are becoming longer and more frequent, and the wet periods, or the active spells, are becoming more intense. So extreme rainfall is falling when it rains. What is extreme rainfall? It is basically defined as some threshold, let's say greater than 100 millimeter per day or greater than 150 millimeter per day and so on, which can actually wreak havoc, create floods and so on and so forth. Okay, so Subimal Ghosh from here in IIT Mumbai argued that the spatial variability of the seasonal mean rainfall has been decreasing, but the sub-seasonal rainfall variability in space and things like the return periods are changing. So I made many new points here, but I didn't clearly explain all of them, right? So global warming and extreme events, what can we do about that? I think the simplest way to think about it as the atmosphere as a sponge. As you warm it, it can hold more moisture. So think about a sponge and you pour water on it, it gets wet, and if you push on the sponge somewhere, it's not going to drizzle, it's going to pour somewhere. So the instabilities that produce convection and rain is like somebody pushing on this wet sponge, and extreme rainfall is that it pours somewhere. That's in a very simplistic sense, but there are many processes which create extreme rain events when you warm the atmosphere and load it up with more moisture. In the Indian region, it's special because a lot of moisture here has to come from the oceans. So it turns out that the Indian Ocean is also warming relatively fast because of the special dynamics that it has close to the north, connection to the Southern Ocean, heat coming in from the Pacific, and so on. Okay, so this is some calculation which is complicated, but basically from M.A. Pathak, who was a student here, now he's a faculty at IIT Kharagpur, which shows where the water vapor moisture comes from. So basically there is a lot of recycling of the rain that falls before, and there is a lot of water coming from the ocean. In the global warming context or in the El Nino La Nina context, this means ocean warming, land warming together determine the seasonal distribution and seasonal amount of rainfall. This is what is the challenge of understanding the monsoon, not only with global warming, but also in natural variability on a seasonal time scale. Okay, there is the onset. Prediction of the onset is always interesting, even though it's not clear whether it really means anything in terms of the seasonal amount of rainfall. And there is the withdrawal, and there is the length of the rainy season, and the distribution of the rainy season, of rain in the rainy season in time as active and break periods, and the spatial distribution. So monsoon is a very complicated monster in that sense and is a great challenge.